Welcome to today's video, where we're going to learn about the decorator pattern and how we can use it to enable caching in an enterprise system using Java. The decorator pattern is a design pattern that allows us to dynamically add functionality to an object at runtime. This can be useful when we want to add functionality to an object without modifying its source code. There are many common use cases in enterprise-level systems that can benefit from this pattern. You can use this pattern to enable logging, caching, authentication, validations, etc. Today, we will focus on caching. Caching is a common technique used to improve the performance of applications. It involves storing frequently accessed data in memory so that it can be quickly accessed when needed. In this video, we'll learn how to use the decorator pattern to implement caching in an enterprise system using Java. First, let's discuss the way you might approach the problem without the use of a decorator pattern. As an example, imagine the class below. This class implements an interface and contains a single method used to read some data from a source. In a real-world application, this method can return data from a database or invoke an API to retrieve some data. In either case, the ID is the key data element used to pull data. Now let's imagine that in our case, the data is pretty static. As an example, reference data values, or values often used in dropdowns, are a good example of this type of scenario. These data values do not change frequently, but are accessed often, an ideal candidate for caching.
We are going to use a simple caching strategy. A map data structure that uses the ID as a key and the returned value from the getById method as the value to store in the map. Of course, in a real implementation, you would use a caching framework. Here, we add a simple map to the data reader class. Additionally, we have modified the getById method to first check whether the cache contains data for the specified key. If so, we pull the data from the cache and return it. Otherwise, we go to the source to get the data. This could be a database or an API call, etc. Once we get the data, we store it in the cache for future use so that we don't have to go to the source each time. At this point, we may be tempted to ask ourselves, why do we need a decorator? After all, this implementation will work and is functionally correct. In our case, we had access to the source code of the data reader class and could modify it. In some cases, we may not have access to the class. Additionally, we only implemented one additional function at runtime, caching. What if we wanted to add additional features, like logging or authentication? Very quickly, our data reader class will become large and unmaintainable. This type of situation can be avoided easily if we follow the principle of single responsibility, which states that any class should only be responsible for one type of behavior. In our case, the core function of the data reader class is to read data. Let us now move the caching function out from this class into a caching decorator. First, we create the data reader decorator class. The key thing to note here is that the decorator contains an immutable instance of the thing being decorated, in our case, the data reader. Additionally, we override the getById method and point it right back at the thing being decorated. The reason we do this will become evident in a minute. But note that in keeping with the single responsibility principle, this class acts as a decorator without knowing what type of decoration we are implementing. Now we specify the type of decoration we are implementing. In this case, we implement caching by using a cached data reader decorator. This class extends the base decorator class and adds a dynamic behavior, caching. We override the getById method to check whether the item exists in our cache. If so, we return it from the cache. Otherwise, we get it from the source, add it to the cache, and then return it. This implementation is in keeping with the principle of single responsibility. Our data reader class only reads the data. Our decorator class only knows about decorating the data reader, and our cached data reader decorator only knows about caching. Well done. To implement this pattern in your application, create a decorator for the thing to be decorated. For each type of decoration, create a separate decorator, such as a logging decorator or an authentication decorator, etc. Finally, use the decorated object just as you would the original object.
We hope you enjoyed this small step on your journey to becoming a better programmer. All the best! If you like this video, give us a thumbs up and subscribe to our channel. Your support helps us reach more people and help others become better programmers. Thank you for your time.
To use this pattern, we simply replace the use of the thing being decorated with the decorated thing. Without the decorator, the code always goes to the source. With the decorator, the first time we pull data for a given ID, we go to the source, but every subsequent time, we pull from cache, a big improvement.